Hello everyone, welcome to Coder and Boots. So in this video, we are going to discuss about the topic how to develop and deploy Python Flask applications in production. So I'm going to explain about the case of developing REST APIs using or the productionization of the REST APIs developed in Flask. Okay, so this is going to be like a simple, maybe like most of the people who develop Python might be aware of this, but if you are new to this, maybe like this will be helpful for you to get started or maybe to get organized. So I'm going to cover two major topics in this video. So one is the code structure part, okay, and the second is the deployment part. Okay, so the code structure is very important while developing large scale REST APIs or web application. Okay, if you don't follow a structure, so during my initial days of my career, when I was developing Python based application, so I was not following a proper structure. So I was just writing Python programs in simple the Python files, and then call the modules one by one based on the need. But what happened is, over a period of time when we started developing large applications, so it became very complicated to manage the code. It became very difficult to add features, collaborate, all those kind of things became very complicated. So later, I came up with a structure that I followed, and I passed it to so many people. Now it is used across now I can see that is used across a lot of people. So I felt it is useful, so I thought of sharing it with you guys as well. Okay, so maybe instead of get explaining a lot in the PPT, I'll get into the code part. So this is my PyCharm, my favorite Python IDE. So I've been using this PyCharm right from the beginning of my Python journey. So now even there are a lot of other IDEs like VS Code, okay, and so many other things, but I still use PyCharm. Yeah, so you can use the IDE of your choice. So what I usually do is, so here in the PyCharm we can create new project. Okay, so here this we can create new project. You can put the project name, you can select the project location, and if you want to initiate or create a Git repository, you can click on this, and then this is basically the local Python execution environment. If you want to go with the virtual environment, you can select this, or if you want a custom environment, you can select this. Okay, so it's up to your choice. These are all Python basics. Okay, but what I'm going to focus is more on the structure of the code inside this. So this is basically for a web API. Okay, so web API means a package with a lot of APIs, and maybe there will be front end for it. The front end means basically a user interface. The user interface can be a mobile application or a web based application. Okay, so this is the backend part. Backend means basically the APIs behind the user interface. So I define the project name. Then inside that I'll create basically a directory called conf. Okay, so conf is basically for storing the configuration files. So usually I create a configuration file app.conf. So inside that I have config section, then the key value. Let's say if you have some other config section, you can have as many config sections as you want. Okay, so maybe or something else. Okay, so MySQL something, or so you can have as many config sections you want. So it's always recommended to segregate the configuration based on the theme of it. Okay, so if it is database related, you keep a section and keep the key value associated with that. So if you open any standard application also, you will see this kind of categorization, so that it will be very easy for the end user to configure it, because once you develop it and deploy it in the production, then it will be managed by the support team. So for them it will be very easy to understand and manage this configuration. Then second is a package. So difference between a package and directory is, till Python 2.8 I think it needed like a underscore underscore init.py inside a directory to consider it as a package. But later on from Python 3.x onwards, I think even 3.2 onwards, we don't really need an init.py. So automatically, if there is a Python program inside it, any Python program, Python module inside it, it will be considered as package. Okay, so I have created like a scripts package. Okay, scripts is where all my code goes in. And so let's explain the first layer. Conf, we have app.conf, then we have scripts. That is where all the modules configuration, the code goes in. And then we have a app.py. This we can say like the main or main executable. Okay, so all the execution will happen from here. Then we have requirements.txt. Requirements.txt is very important, where we have the package dependencies and its version. So this version is very important. The reason is, if you don't specify the version, this version gets updated periodically, and over a period of time, when you deploy this package application, the packages will get installed with the latest version. Okay, and your application might break. Okay, so because depending upon the version changes, there can be drastic changes within the implementation of functionalities within a package. So always keep the exact version of requirements, okay, inside this requirements.txt. Another thing is, always maintain all the list of dependencies in this requirements.txt. The reason is, otherwise it will be a lot of trouble for people to deploy this application in any environment. Okay, so now first level we have explained. Okay, app.py, I'll get back to this app.py later. So then inside the scripts, I have again another packages like config, okay, core, exceptions, logging, utils. Okay, so config is where I store basically whatever configuration file I have here. I read the configuration values in the app.config. Okay, the reason why I'm reading in this module is basically, instead of reading this configuration across all the modules within because there can be a lot of functionalities. Think about like a Facebook kind of application where we have so many features: login, profile, homepage, posting something, okay, shorts, lot of things are there, right? There will be APIs related to each of these section itself. Okay, and there can be configurations as well. So instead of reading the configuration file across all the places, so what I usually do is I read the configuration file in a single module called app.config, and then read all the configuration parameters here, so that tomorrow, let's say if there is any modification in the configuration file, or let's say if you want to change the name, or if you want to make any changes to the key or something, so it's very easy, because you don't really need to make changes across the program. You can just manage the changes from here. And another beauty of this app.config.py is, today let's say you are reading the configurations from a configuration file. Okay, so tomorrow if you want to read the configuration from a database, what you need, you can basically make changes over here to read the configuration from the database. You don't really need to make any changes in the remaining parts of the program, because it's all driven from this particular section. So I use like save config parser.read the config file, then get values section and the key. These are all standard Pythonic things. Okay, so I'm not going to get into the basics, okay, but I'm just focusing on the structure part. Then next part is app constants. App constants is where I define all the constants. Okay, so here let's say like so this is I just created like an empty module, but you define you can define all the constants over here. So you can it's up to you, like how you want to define everything. Okay, so that is why I created constants over here, so that people can refer and change it later if you want. Then next package is the core. Okay, so core, I have two packages. One is services, second is handlers. Okay, in case of Flask, it is just services and handlers, and in case of FastAPI, so what we do is we have something called models as well. I usually keep something called models as well. So model is basically I use the Pydantic models inside the models package. So in case of Flask, you can also, so it's always good to keep the models in Flask as well, so that your payload will get validated so for basically like instead of we can basically define the structure of the payload and validate it. Okay, So the services and handlers is basically all the APIs, okay, API endpoints. Okay, so we will create services module for every specific service. Okay, let's say you have an application, so and your login services, okay, login and the login related things will all go in the login services module. And let's say maybe another thing is message or chat services. Okay, so chat and all the chat related things will all go inside the chat services. Okay, so in this way we can segregate the services by, so it's not just one endpoint. Okay, I'm not saying just one endpoint. We can have all the login related endpoints inside this one. Okay, and the way I create this services is basically using Blueprint. Okay, Blueprint is a very powerful feature within Flask where you can templatize. Okay, so you can modularize things very easily. Okay, so instead of just considering it as a normal module, what I do is I create a blueprint for login. Okay, and then login dot route, okay, path and the methods we define. Okay, and inside the services, so what I usually do is I create, I'll usually people will keep something to validate the cookies. Okay, validate the basically like I mean the authorization part. Okay, so there will be some functionality, so I have not implemented that functionality over here, but you can implement the authorization part here. Then the logic, okay, the actual processing logic. So the processing logic I usually don't keep it inside the services module. I keep it inside something called handlers module. Okay, so that's how, like I mean, for every service there will be a handler. That means login service I'll have login handler. Similarly, chat service I'll have chat handler. Okay, so in this way the program will be modularized in a very neat way. Okay, so the another beauty of this mechanism is let's say like I mean you have six of a lot of developers working on this program, okay, application. So let's say you are giving one developer to develop chat. So what they need to focus on, they just need to develop the services and the handler part of it. Okay, and the remaining places like I mean the configuration or wherever, whatever updates they want to make they can change, but their work will be mostly focusing on just the handler and the services corresponding to it. Okay, so maybe they will have some specific exceptions, but most of these custom exceptions, everything will be defined at the application level, so they don't have to really work on that, but they will just focus on these two files and they can integrate very easily. Okay, so and similarly like I mean chat services, like this we can have n number of services and handlers. Okay, and services will be very lightweight. We'll have the authorization mechanism, then we'll be calling the functionalities within the handler. A handler will have the complex logic implementation. So logics will go inside handler, the API part will be handled inside the services. Okay, and all these APIs, okay, so these will be enabled or activated or integrated at the app.py level. So there what I am doing is I am importing the blueprints. Okay, I am importing the blueprint, for example the login blueprint. So then there I define the Flask app, and then there I define app.register blueprint. Okay, then the whatever blueprint we have, right? So that blueprint I mean we register there. So the advantage of this is you can scale your application to, or let's say like I mean you have login services there, then you have maybe a report generation service, you have a chat service. If you want to scale some of the scale means, let's say the load on the chat service is very high. Okay, so you can have multiple copies of this code deployed by simply commenting the unwanted modules and just enabling the required modules. For example, so I have something like this chat. Okay, so if you want chat only, or if you want to run only the chat feature, what you need, you just need to comment the login part. Okay, so then what will happen, the entire, even if you have the entire code inside this, only the chat related APIs will start. Okay, the remaining things won't be available. Okay, in this way if you want to replicate or scale or and you can keep within behind a load balancer, so you can have multiple deployments of the chat, maybe 3 or 4 instances of the chat and 1 instance of the login. Okay, so depending upon this you can scale. That means I mean the concept of microservices comes, so you can you can scale individual APIs or individual group of APIs, okay, so in the way you want, okay, and you can collaborate with a lot of developers because they can all engage without disturbing the code. And let's say if there is a bug, okay, so without making the entire system break, what we can do, we can just disable the feed or disable the particular section where it has the bug, okay, by just commenting the corresponding blueprint. Okay, so this is the beauty of this structure. And then let's get into the remaining packages. Okay, so I explained core, so handler, services, models, and exception. All the custom exceptions we'll define inside the exceptions package. Logging, all the logger related things like rotational logger, okay, file logger, or if there is some socket logger that goes to some log aggregator, all those we can define in the logging section. Utils, all the utility packages will go inside the utils. Okay, and so that means this covers, I mean, most of the requirements related to REST API development. Okay, so this structure is applicable for Flask, FastAPI, so any web service. Okay, so and this is just, I mean, based on my experience I prepared. So you can, if there are any better structures that you follow, feel free to comment below this video. Okay, so that is about the structure part. Now let's come to the deployment part. Okay, so if you see this app, right, so by default if you start a Flask application, you will see a message running in. Maybe let's run this. Okay, you see, warning, this is a development server. So I just opened a simple program. Okay, this doesn't have any structure or anything. I just opened a simple Flask program. You can see when I do app.run, it's giving me a message warning, this is a development server, do not use it in production environment, use a production WSGI server instead. What is WSGI? It's web server gateway interface. Okay, so the default WSGI inside the Python Flask is not a production grade WSGI. Okay, even if it runs, it starts APIs, everything, it's not something that is classified as a production grade one. There are a lot of WSGIs available, and one of the popular WSGI that is used in or that is very popular in the Python world is Gunicon. Okay, so people use it as part of Flask, people use it along with FastAPI. So and it is very powerful. I have been using it for almost, like, I mean, 10 years. So it's very powerful. So I'll explain you how to deploy this application using Gunicon. Okay, so never run your application directly using app.run in production. Always use a Gunicon. Okay, so that will take care of running it in a production grade way, and proxy it. Okay, so once you run it in Gunicon, next is, like, I mean, we'll have to proxy it behind an Nginx or some web server, so that, I mean, you will have the endpoints proxied behind SSL certificates, okay, and with all the security measures enabled. Security measures enabled means like, I mean, I have already explained in my previous video about protecting the endpoints from brute force, DDoS, DOS, botnets, everything. Okay, all those configurations, there are a lot of configurations available the Nginx side also. Okay, that will protect your API. So a layer of Nginx, then Gunicon, then Python app. Okay, and the Python application, your application can be deployed directly on the machine, okay, or inside Docker container, or as, like, I mean, a deployment within Kubernetes. It's up to you. So I have gone through all these stages. Initially, long back, I mean, my applications were all directly running on the machines, then Docker, then recently, like, I mean, now most of the applications are deploying Kubernetes. Okay, so right now, but the deployment steps are similar. Internally, how it runs are similar. It's all about, I mean, how we package it, and then the remaining life cycle part of it. Okay, so I have installed so I'll just explain, I mean, how to run the application using Gunicon. So one more thing is, while deploying, always use virtual environment. Okay, always use virtual environment for deploying the application, so that you will not create any package related conflicts. Okay, otherwise you will face a lot of package problems, because the reason is, when you do deploy, or when you do the package installation using requirements txt, that means, I mean, pip install -r your requirements txt. requirements.txt. What will happen? It will install all the packages with the corresponding version from your requirements.txt in the Python environment. So if you're not using a dedicated virtual environment, what will happen? It will update the packages over there, right? So it may impact the operating system if you are installing it as the root Python in the root Python. It may impact other application if you are installing it in Python environments where other applications are running. So always create your application specific virtual environment. That is very important. Second thing is, never run your application as root user. If you run the application as root user, if by any chance if an API is vulnerable or something, what will happen? The attacker can get into the root access because it can execute some commands from your program, from your API, and then it will lead to a lot of other damage. Like they may get into the machine, they will be able to access everything inside the server. So that's why always provide the least required access to the user that runs your program. Okay, that is another important thing. Now I'm just creating the simple app.py with this simple Python program. So I'll show you how to run this. So you can find a lot of detailed documentation of Python Flask, everything in the official website. So you have to install the package, Python package. You can install it using pip install Python. So it's available in the PyPy repository. So as of today, the latest version of package is Python 22.0.0. So and this package also, this Python also, you have to keep it in the requirements.txt. Okay, so the way to run is Python. So here also, if you see Python app.py, you see it runs. Okay, but with Python, what we can do, Python. Okay, once you install the Python package, the command line will come. Okay, app :app. Okay, -b. Okay, so I'm just giving, so B is the bind, okay, and the port. We can define the, so here if you see Python and app app is the this module. Okay, let's say your module name is something else, you have to give that module name over here, and app, the second, the after the colon you have an app, that is basically the name of the Flask application. Let's say your Flask application is with some other name, ABC, then you have to give that name over here in the after the colon. Okay, -b basically stands for the bind. Okay, so here you have to give the listen address and the listen port. Okay, so even if you see in my program, I'm using port 8000. Okay, 8000, but outside with Python, what I did, I used a different port. So whatever I'm giving as part of the Python is what it will get picked up. Okay, it won't use the port inside. And another thing, if you see, by default, you can see there is something called using worker sync and booting worker with PID 381853. Okay, so basically when you start your application with Python, by default it will start two processes. Okay, let's verify that process. Okay, you will see. Okay, you can see there are two processes corresponding to this application. Okay, one is the Python and the second is the worker. Okay, so this is what I mean. You can see, like, this application is running at 8080. Okay, so one is the parent process and second is the child worker process. Okay, so we can have one more thing, we can specify, that's like, you can see shutting down master and shutting down worker. Okay, worker exited, master exited. When I cancel, we can specify the worker. Okay, worker like 3. So what will happen, it will provision 3 workers. Okay, so 3 workers means 3 different processes. So every worker is associated with a separate process ID. So that means this is like, parallel processing. Okay, so that means this will be able to handle. Okay, so or process three things in parallel. Okay, so that means, let's say if your application is CPU intensive, there are a lot of requests coming in and you have some complex processing inside that. Depending upon the CPU available in your system, you can scale this application. You can configure the number of workers, and within the worker, what you can do, you can configure something called thread. Okay, so this is a process ID, right? So within a worker you can configure threads as well. So that means a process will be subdivided into threads. So for let's say, like, I mean, if it is less CPU intensive, if you feel, then what we can do, we can specify a number of threads based on that. We can increase the threads up to some number. Okay, so that means you can specify the workers and threads along with Gunicon. So even if, let's say, worker process fail, so you can see this ID, right? So what I'm going to do is I'm going to kill this worker process, kill -9. I'm just killing that specific process. You see, automatically a new worker process got provisioned. Okay, it won't kill the entire application, it will just restart and create a new worker process. So in this way, the application won't fail. Okay, so even if, like, I mean, there is a problem, it will still restart. Okay, and yeah, another thing is, I mean, for monitoring the stats of Gunicon, there are several ways we can export the stats or the performance of this application. Okay, and also we can send a lot of commands to this particular Gunicon. There are a lot of things associated with Gunicon. I'll explain. I'll take a separate video related to Gunicon. Okay, so right now I'm not going to get into the detail. Yeah, but the core is, like, I mean, you have to deploy this application with Gunicon. And one more thing is, let's say if you're deploying your application Kubernetes, then based on my experience, don't specify the workers, you keep the workers as one, because you can do the scaling using Kubernetes ports, because anyway ports are also doing similar scaling, right? So scale it using Kubernetes ports and keep the worker as one. You manage the threads inside each of the pod. Okay, so but if you are deploying directly on a machine, you specify the workers and threads. Okay, so because depending upon the CPU available, CPU and memory resources available in the machine, you specify the number of workers. I hope this example is useful, this video is useful, and if you have any questions or comments or feedback, feel free to comment below this video. Okay, thank you very much for watching.